Hello again, and welcome to my fourth video of porting Earth 2140 into OpenRA. For today, I have one specific goal which I want to achieve, and I'm sure we will do this, or we will, get it achieved. And that's basically, I want a completely working unit in-game. Not on the balance side, of course, not on the stats, not on the projectile offsets, which is basically standard OpenRA modding. What I'm talking about, I want to get one tank in game with its body, with its turrets, with the correct movement, rotations. Yeah, that's the goal for today. Um, we are actually at a state where we don't even have the proper unit rendered with palette and so on. So the first thing I would like to start with is actually loading up the correct palette and making the unit look right in the asset browser, because that's basically the requirement we have to to make it usable in-game, or it will look just too weird. We actually can already use the sequences, because whatever shows in the asset browser is actually usable. But if seen in the last video, it just looks bad in the current state. So yeah, let's start. What we actually want to do is at first we want to load the palettes. If you look at this, we had this commented out. So now we are basically going to make this implementation, which is actually not much, but yeah, and we need to remove it from here because this is just the sprite loader. First of all, the question is, how do the standard palettes work? They're basically traits which have to be added to the world actor, so they are globally available in the world, and then specific actors can basically say, hey, I want to render with this palette. What we actually want to do now too. So let's first look about palettes. So you can see there are quite a lot, and I think a good example would be not to use the internal VGA palettes. But let's use this one because this is an external palette file format, and I think it's a good basis to work with. So as we can see, this is basically an OpenRA trait. The trait itself is basically here, but what you can actually set the traits in the YAML. So it needs the correct trait info, which is basically everything you can configure YAML-wise, which then gets added or gets given to the trait itself. And this one here receives the info, it stores the info, and you can basically, if you just look at where it is used here, file name here, it can then use all these informations which have a default value here, but can actually be overridden in the YAML files. So this is the first thing we actually want to implement for our Earth palette files. So yeah, let's get this started. So if you look, the palettes are always in the mod project traits world, and then the palette, because they are added to world, of course. So let's create traits. Now inside traits, we will create world, because that's actually the namespace where we want to put this in. This namespacing above here, basically this is a strange thing in OpenRA. A lot of traits are actually using this namespace. We won't do this. Basically, we will add a dot world behind here, because I like to have clean mappings between namespaces and folders. But yeah, that's just some personal. Yeah, I just like it more. Yeah, anyway, so okay, let's start. We will basically start with a new class. The other classes are called palette from whatever file. So we are calling this palette from, and now the interesting thing, we don't have a single palette file somewhere. So basically, how we are calling this is basically from mix. But I won't add file here because it's not a sole file which is somewhere in the folder structure. Okay, so this could be our trait. Yeah, it's very empty. Um, but it won't actually work because a trait always needs a trait info. And the trait info has to be called the same as the trait plus the word info, and it has to implement the iTrait info class. So, sorry about that, not class, interface, of course. So we implement the members, and there we see this is our create method, which actually I will put this all in one line because actually, yeah, OpenRA does this at all places, so almost all places. So we'll basically do the same. So when a new palette is created, it basically creates a new info object. It fills all the properties and then calls the create method, which will then initialize the correct trait and return it. So for now, we will just do return new palette from mix. And yeah, that's it. We will add everything else where we need it. So something else we actually need is basically this. There's an interface iLoads palette, which basically allows this trait to load palettes, obviously, but they won't show up in the asset browser except when the iProvide asset browser palette interface is being implemented. So we just copy them here, and we import the missing. Come on, import missing functions. Yep, here we are. I don't like the order. So this is basically what you want to do. We want to load a specific palette here, and we have the palette names thing here. It's the same as here. Come on. We have the load palette method here, and of course we have the palette names here. So what we want to do is basically copy the contents of this. However, if you look, it's doing a little bit more. It looks at world tileset stuff. Actually, we don't need this. All we need is basically this. So this is all what we're going to do. We will just say, okay, return this. So, and there can't be a setter, of course. Now we need the info object. The info object is actually this thing here. So this one needs the info object as a parameter, and it has to store this. So let's put this here. Let's call this info, and let's store this. This info is info. Okay. So the next thing actually requires a name. So you can see here, this is actually the name of the palette, obviously. So let's just copy this because it has some interesting stuff like it has a description, of course, for the documentation generation of the traits. So yeah, so basically we have the palette names thing implemented, and it returns the correct name. The next thing we actually want to implement is load palettes. Yeah, load palettes basically needs to read the palette and add it to the world, so we can actually use this palette in game. To read the palette, we basically move here to our sprite loader, because this is what. Why is this happening this the second time? So basically, what we want to do is we need this part here where we basically read the mix file and copy this here. So basically, this is the reader, of course. We don't need this because we know we always have a mix file in here because we can name which file we want to load. And yeah, just yeah, do it like this. As you can see, we need a stream, of course. If you now look in this palette, for example, you can basically do world map open, and then you tell him which file you want to open, and you get a stream. So for now, we will basically just do the same. Yeah, let's use a using. And let's give it a correct name. Let's call this stream. do all the stuff with the stream, and then we are done. Okay, the next thing it needs is basically, which file do we want to open? This is a parameter we actually need to name when we add this palette type to the world. So if we basically say we want to add palette 50 to the world because we want to use palette number 50, then we need to name it. So for now, we will basically copy this because this is the file name. It's always, as again, required. And yeah, I could have typed this, but now we have the nice description and the required already there. So I don't need to retype this. And the next thing is actually we need a world to add it. As we can see, we get the world renderer. World renderer. But we don't have the world itself. How are we supposed to get the world? Well, this is basically an interesting concept because when you create, or when new traits are initialized on actors, the create method is used and it gets an actor initializer. The actor initializer basically, let's see, contains the actor reference, so you can basically access different traits or whatever. And it has, of course, the world where it's get added. So basically, this is the information we want. So what we basically want to do is we'll just no, today's not my best day on typing. We'll add this parameter, and now we can do something like world. Come on, typing too fast. We are taking the world from init, and yeah, we are creating this field. So now we have a world. As we can see, it's no longer red. So yeah, we have the world. We are basically opening the palette file. No, the mix file. This hasn't to be a physical file on your disk. Okay, physical is a little bit weird, but it actually searches for this file name in the loaded packages, which obviously can be a WD archive, because yeah, it will check for contains, and the WD file which contains an entry with this name will be used, and then it calls getStream. And this will basically return the stream here for this file. And basically, exactly this is what we get here. So now we have the stream, and we can start reading again. So in this case, we don't care at the for the identifier, and we don't care about the data size because yeah, the image data is basically useless for us in this case. We don't need this sprite frame stuff. So basically, let's call this again num frames. Then we have the images offset, which we don't need because we don't want to parse images here. But we always need to read this stuff because otherwise the cursor won't be at the correct position. Thanks, autoformatter. Okay, so what we, however, want to read is we definitely need the first palette ID. And we don't need the number of palettes. Might sound a little bit strange, but actually in this trait we will actually tell him which palette we want. And if we basically say, okay, we want palette 50 and the first palette is 45, we will subtract this value and we get number 5. So we can basically jump over 5 times a palette and we are at the right position for this palette. So we really don't care about all other palettes, and we don't need the number of palettes. Yeah, then we of course have entry, and then we have the image offsets. But we don't need them because we will skip the images on this time. We only care for the palette. And as every offset is basically a size of an integer, what we can do is actually tell the stream to move the cursor by num frames times 4. And yeah, now we basically have skipped this whole block and we are here. So we are reading this string again, which is pal. And now we basically need to jump to the correct palette. So again, we basically do stream position. And now comes the interesting thing. We need to name the number of the subpalette because this will basically the mix file. So you know what? I will just copy this, make this an integer. Let's call this sub subpalette. Let's yeah, do not use a default, so it's an int, so it will be 0. Yeah, just call it subpalette to load, and it's of course required. So now we have a new property called subpalette, which we can define in the YAML. So we can basically say, hey, give me from this mix file palette number 1, 2, 3, or whatever. And yeah, so we want to take the subpalette, which we basically want to take. For example, use number 5. Then if we use 5, this means that we basically need to shift this by one palette, which consists of 256 colors and 3 bytes per color, red, green, and blue. So now we should be at the correct. No, wait. We are not, because as I said before, we have the first palette ID. So the first entry here, so palette offset 0, is this ID. So if we basically want to do the enter the right subpalette ID, we basically need to subtract this. So we will basically do something like minus this, and here we go. Now, if we want, if we are starting at a 45 and we want to get number 45, we will basically get 0 times, so we will basically get the first one. So this will basically fix this for us. At next, we are at the correct position now, and we want to reach to the colors. So yeah, basically we need an array where we want to put the colors in. Let's see, I think it's using unsigned int. And if I'm not mistaken, there is a palette size. And you know what? Let's use this here too, because I don't like magic numbers. So now we have an empty array. Empty means basically every value is 0, and the OpenRA palettes are in ARGB, so they are all now black and not visible because they're completely transparent. So now we need to read the correct colors and put them in here. So basically what we want to do is create a simple for. Let's go over palette size. Skip this here. And oh, we don't need the brackets here because we are just actually doing one thing. We are reading the colors and putting them here. So if you do this, it will be the same as above. This is a default value. So we now want to basically add ARGB. In hex, it would be this. So some spaces. And if I'm not mistaken, the order is this in the Earth palette files. But even if it's not, we can simply swap the fields, because mostly it's RGB or BGR. I never encountered a file where it's something else. It's always one of these. Well, for the games I reverse engineered. So so we can actually see the palette here. We knew it has a size of 3 bytes. Doesn't have an alpha byte, which will basically mean if we don't set it, all our colors will be basically there, but not visible because their transparency is 0, so you won't see a thing. So the first thing we actually want to do is we create a byte with a maximum byte value, which is this. And we basically move it by 24 bits to the left. So basically we created an FF here. I removed it 8 to here, another 8 to here, and another 8 to here. Yeah, so now he wants us to cast this because there will be an integer, so we just cast this to uint, and what does he say? That's interesting. Let me think. Let's just finish it like this first. So we need another pair of brackets because actually we now need the other channels. So we have moved them 24 bits to the left, and now we will add a rat. So basically we just say hello stream, read the next byte. Oh, now we don't need this checked stuff. Nice. So we are reading another byte. When we read a byte, the value will be put in the lowest bits basically, and we again need to move it this time 2 times to the left. So let's just move this 2 times 8 is 16. And now read the next byte and move this by 8. And then now read the next byte and in theory move this by 0. We don't need this, of course, but I will keep this here because if the format is wrong, we can simply adjust these numbers, giving this a 16 and making this 16 0 or whatever, so it works out. So this should be basically the way to read the whole palette into this array. Now we need to add basically the palette to the world. Let me see how this works. Same as here. It basically reads all the colors. Here it is. Basically, this adds one renderer add palette, gives a name, the palette itself, and allow modifiers, whatever this is. I won't go into detail about that. So let's rename this colors. Okay. Allow modifiers. It's actually a parameter here. We will just use the same as we have here. It's a bool without any description or whatever. So yeah, just copy it. So we have the same behavior here. Okay. This should work if I'm not mistaken. Let me check. Okay, when we call load palettes, we actually opening this file, reading the stuff here again, filling the colors in, and adding them to the world. Looks good. So the next thing we actually want to do, let me see where I have my Sublime open here, and here we are. The next thing we want to do is to make this palette usable. So in our mod, basically, we have empty folders. Okay, we will basically create a new rule file. Let's save this and call this palettes YAML. So this will be our YAML file where we add the palettes. Let's see how, for example, Red Alert does this. There's also a palettes YAML here, like this. So we just copy paste this here for now. Okay, if you now look, this is basically the trait which is being used without the info, of course. So palette from file, and we want to do palette from mix. Now we need to give it a name. If I remember right, let's mark this here because I'm absolutely sure it was like that. First ID was 45, and the number of IDs was 35, if I'm not mistaken. Yeah. So okay, we now need to add all the palettes to the game. We don't need shadow index. We basically need name, file name, and sub palette. So let's start with the first one, 45. We need a proper name for them. So let's just call them palette 45. And let's enter here palette 45 because this has to be a unique. This here is a unique property. Otherwise, they will basically override each other. So everything behind the add will be obsolete. But it basically makes if you have 2 of them. So now this one will override this one, and if you name it like this, they won't override each other because they are different keys. Yeah. Anyway. So we have palette 45, and we basically have the file name here. And if I remember right, it was sprites units 0.mix. yeah, I think that should be it. So the last thing we need to do is to add this to the mod YAML because it has a list which rules have to be loaded. So basically, we're going to copy this one, load this from RS2140, and now the palette should be in-game. Let's start this. Here we go. Yeah, it's there. So, as it's the first palette, let's. I think they were basically having the same order as the sprite sheets. So yeah, this one will fit. It will fit here. It won't fit on the later ones because they're using a different palette. So yeah, they look a little bit broken. But it's actually interesting that most of the units have almost the same palettes. Weird. But okay. Oh, this is interesting. As we can actually see, this is definitely not how it should look in-game, with the black border, with the red, whatever this is to the left. We will look into this later. Let's first try to adjust this palette. We need to debug the palette. So what we need is a more detailed information about the palette. We can of course go into the hex editor again, or we can just be lazy, which is what I'm going to do now. So here we are actually reading the palette. So instead of just starting in the hex editor again, we'll basically create an image displaying the palette. So let's call this one a debug. Let's make a new bitmap. As the palette has 256 entries, we can basically do 16 by 16 and make this one. Do we have an perfect. So now just iterate over this again. We go through all the colors. We just say X and X, Y gets basically the color of this. And because actually, 16 times 16 is 256. So we should have a nicely looking palette PNG at the end. Okay, so for the X value, it's basically we want to draw this row-wise. So we're basically doing this. So we will always have 0 to 15, and then again 0. On this side, we are just doing this, with basically, it's an integer, so it will be 0 for everything till the 16th 16th index. Then we will have 1 here and so on. So basically, this will, map the whole colors to this 16 by 16 block. And the last thing is actually, I think he just wants this to be unit is not assignable. Okay, so he wants a what he basically wants is to make a color for this, I guess. So we will just, instead of this, do a color from ARGB. And now he tells us, hey, I want an integer, not an unsigned integer. Okay, well, anyway, works. The last thing we want to do is now to save the palettes. So basically we say, or we do debug save. It needs a file name where we want to write this to. So why not just use info subpalette, because we might extract multiple ones, and just append PNG. So now every time this trait gets loaded and it parses one of the palettes, it will basically build us a debug image, so we can basically see the palettes. Let's try this. Okay, game is starting. Okay, the game has been started, so all the palettes have been loaded. We can now instantly exit this game. And if you look here, we have a 45 PNG file. And if we look here, this looks bad. Let's see another application for this. a good old paint, of course. Let's zoom in. 800 is maximum. Weird. Okay, what you can actually see is this is the color palette. But this last row is pretty interesting because actually the last row contains something which, yeah, I don't know what it is, but it looks weird. I think we'll find out later. So obviously we had some black around the image, which is basically the transparency. And if we remember where we were filling up the image with transparency, here, where was it? Here. We are basically just skipping these pixels. So the default value for transparency pixels will be 0. What basically means that in our palette here, we need to start at 1. We can basically completely... Oh, wait, no, we cannot start at 1. Yeah, we need to do this afterwards. We basically need to... let's do the complete version. We will override the first color with a black, which is completely transparent. This will basically make everything which uses the color number 1 use the transparency channel color. So if we now start this, yep, as you can see here around, there's no longer a black box. But still we have this red. And if you look here, it's absolutely clear that the last line has a very special use case. It's basically not really, come on. It's not really part of the palette because the palette will be up here. So the green parts here in the image are basically the player color. And if you look at this palette, we have here one block containing only these green pixels. So this is kind of interesting. This is basically the player color which gets replaced here. Then we have blue. I don't see blue here. Let me see. Do we see anywhere blue? Oh, wait. There was blue. Here. So actually, this looks like the muzzle flashes when shooting are attached to the image because this is a particular gun. It starts here. Yeah, these are all frames of this gun. So yeah, the blue ones will be the muzzle flash pixels. And if we look at the tracks of this unit, they are actually in some orange colors. So these are the tracks. Now you might ask, why did they do this to the tracks? Because I just noticed this is the complete unit. We have exactly, yeah, there it transforms. So what we have is 9 images. There is no move animation. And in the original game, the tracks are moving when the unit moves, which basically means that when this unit is moving, these colors have to be cycled. This will be pretty interesting to implement. Yeah. So okay, we have tracks, we have the blue muzzles, we have the green player color, and now we have 3 more on the right. One of them is the red we can see here, which is definitely the shadow. But there are more red tones. One very, very dark red tone, or is this black? I don't know. But as we know, transparency is the first one on the top left. I'm pretty sure there's 3 different shadow colors. It doesn't seem unit are used. Let's check something bigger, buildings. Here we can see this. We have a shadow here, which is red, and we have a darker shadow here, which is dark red. So basically, yeah, we have. I think the black pixel is. It could be a transparency, or it could be a very, very minimalistic shadow. So like, I don't know, 25%, 50%, and 75%. Yeah, just that the I don't know, different around. So the red one is definitely 50%, and I think the darker red one is 25. So the black at the end must be 75% shadow. Maybe it's used in some structures. I don't know. Let me see. We have these weird underground stuff. Yeah, there are actually two red colors in here. Yeah, the bright red color is on the outside, and then the inside of this tube we have two red colors, so it might be possible that they are actually the shadows. Yeah, anyway. Oh, here you can also see there are... okay. Anyway, let's just implement this somehow by adding the correct shadows. Because, let's go back to the unit. This one. This one looks... yeah, this looks bad with all the red. So let's replace the red. What we do here is something we can actually do for the three last colors, which will be 255, 254, and 253. And let's just use for the shadow always black, but let's use here 40, 80, and C, which should be a 25%, 50%, and 75%. So let's check this again. Ah, this looks good. And let's check the same on the building. Yeah, we now see two different shades of shadow. Okay, what else do we have? There was actually something... let's do this later. Okay, we have the correct palette, 45. We have the unit, and actually there's something wrong here on the left. We rotate this unit. This is pretty interesting. As we can see on the right side of the unit, there are no tracks visible. On the left side, there are the tracks, but they have some weird offset. So it's very likely this image is still shifted. Let's try to adjust this. Where are we reading the image? Basically, here's where we start to read the data. And it seems basically we are reading from the wrong offsets. So let's try to move it 4 pixels to the right. No, always one in debug mode. This looks better. But it's still wrong. I think 2 more should do. Let's try 6. The interesting question is, if this works out, why 6? I honestly don't have an idea. Maybe there are some 6 more bytes we actually skipped reading. I don't know. But no, I was pretty sure we had the whole file. Now we can investigate this later. So this looks good. Yeah, this looks also good. Okay, nice. Oh, you know what? While I'm looking at this, we can definitely notice that the unit is jumping up and down because we noticed there were no offsets. But I remember, well, there were actually multiple lines starting with the first rows were all 0. But actually, if there is both rows in the board scan lines, the first one is 0 and the second one is 0, we'll basically do nothing in here. So this means actually if there are 0 rows, they are most likely empty rows, but we are actually not reading them. And at the end were also multiple same rows, so I guess that if these two values, or this value plus the next value, if they are equal, then the whole line will be basically empty, because we always have a start and an end. So I think we should just implement that. So we will just compare these two values, and if they are the same, we will just skip this line. And if they are not, well, we are going to do exactly we are going to do this. Let's try this out. It's still working. And here we go, perfectly rotating through the middle. So we still don't have the correct offset, but I think actually all units are centered correctly. Yeah, that looks nice. Okay, so in theory we could work with this. However, we have more palettes. We basically need to add all the other palettes, so we can basically choose any unit we would like to use. And yeah. Oh wait. This looks like a big gun. I think we're going to let's find out which palette this is. So first we will just add all the palettes now. So we need this generated, and as I'm actually a little bit lazy, I will just use a small helper for this. I'll basically use my web browser for this. What we need is basically this line. Yeah, and let's start with 0. Now let's start with 45, and let's go to 80. That should be 35 entries. And let's just, we could do this. However, we are in times of HTML5, so we can actually, instead of this, use these symbols, because this will allow us to do this. So we need the number here, we need the number here, and we need it here. So okay, here we go. Oops. Foo is foo, really. It's an empty string. Okay, here we go. And here are all our palettes. Yeah, I'm lazy, I know. Here we go. So now we should have all the palettes in game. Let's again try this out. Here they are. The first one still works. And I want this big gun to be used. This one. Somewhere at the end. Oh yeah, there were some black pallets in the end, if I remember correctly. So, no, this doesn't look right because the player. No, okay, just looks weird. Nope. This one fits. So what we actually want to do is we want to make this tank. Okay, this is the gun. And here's the tank. Nice. So this is what we want to use basically. I want to get this tank in game. Okay, so yeah, I want to get this in game. So here we go. First of all, I think I definitely need to remove this because I'm pretty sure it has. Yeah, it has generated a lot of palette files. We don't need them anymore. Oh, you know what? Let's compare this one, which we're actually using. And yeah, it has different colors here. The first pixel is basically the transparency pixel. It has not blue, but it has purple pixel for the muzzle. But it has the same setup. And I think these 8 pixels here are not used. Might be wrong. We will just read them out as usual. But yeah. Okay. Let's get this unit in game. How do we get this unit in game? It's pretty easy. We basically need to create the unit. We need to create the sequences, and then it should be in game. So first of all, let's create a new sequence file. Let's for now call this thing dummy. And we need a new rules file. Okay, we will call it dummy, and we will also add a dummy here. So basically, what we want to do is avoid adding a complete unit to the game. We will just clone an existing unit and build this on top. So we're going to the red arrow thing again. Let's go to vehicles. Let's use a tank, and what do we have here? Light tank? Nah. Yeah, let's use the medium tank. So I will just copy this for laziness again. Basically, you can inherit any other actor. So what we're basically going to do is this. So now we should have a new actor in game called dummy, which is basically the heavy tank. However, as this is now called dummy, it will actually use the dummy sequence. So we need to define new sequences in here. So basically, we need an idle. Oh yeah, we have a turret, and I think that's it for now. We don't have any more. So what we want to do? Oh no, you know what? We'll also, just to be sure that everything works, inherit this one here too. And I think it should have the same name. Let's look here. Oh, it's actually in small letters. Then I will use this. Why am I using this? Because the icon and the muzzle. So yeah, basically I don't want to copy this. We will just use this and overwrite this. Yeah, but it's not in capital letters, so okay, let's use this one. Okay, we need to define an idle and enter sequence. So for now, we will just use sprite units 0 mix, because that's actually what we want to use. And now we want to, let's see, in game, what we want to do is start, yes, here with 1233. So this one has start 1233. It has a length of, oh wait, we're instantly using facings. So facings, how many do we have? 9. Okay, this will basically look weird in game, but just let's try to get this in game. And the next one at the turret starts here at a 42. Obviously, we can just add 9. And it should also have 9. Yep, it has exactly 9 facings. So now it should, in theory, load up the sprites in game. Let's try this out. Starting the game.
Battle control initialized.
Affirmative.
Build construction complete.
What do we have here? God damn it. I forgot something. Actually, to get this sequences file and this rules file loaded, we need to add this to the mod YAML, of course, again. And where are they? Here. Just copy, paste, paste, and let's just call this dummy. And the same for the sequences. Just copy this here, use this, and here we go. So now it should be loaded up. And what does it say? Use classic facing fudge. Okay, it's actually using this because of. You still have this open? No, of course not. It's actually using this classic facing fudge because it is set in the original sequence file. We'll just disable this for now. What's wrong this hour? Can I hop into this because I want to copy the string? So let's come here. Let's set this to false. Okay, next try.
Battle control initialized.
Acknowledged.
Build construction complete.
And we have 2 medium tanks.
Build unit ready.
And it crashes because unit doesn't have a sequence name idle. So as we actually know that we have idle, it's very likely it can't find the file. And oh, of course it cannot, because actually what OpenRA, or in specific the RA mod, is basically doing is it will add this to the file name because it is told to do so in the defaults. We can disable this just by using this. So it should not automatically add the default extension. And again, this is the the most stupid thing when developing stuff. You basically are watching more at the loading screen than you're actually developing. Yeah.
Battle control initialized.
Acknowledged.
Okay, so here we go. War Factory. Let's
Build
build
unit
it.
ready.
There we are.
Waiting on.
Okay, the pallet. We let's make a mini to do. So we need to add the pallet.
Affirmative. Affirmative.
So it is actually rotating. So let's okay, up is correct. So if we now go to the right,
Acknowledged.
it crashes. This is pretty interesting. Why did it crash? Unloaded sprite. That's a weird one. Let me think. What are we doing wrong? Do we unload anything? No, we don't. So let's ignore it for now because at first it worked. We'll eventually find this later. So yeah, let's start with adding the palette actually. What we basically need is the default trait render sprites, which is basically defining the palettes to use, and it's using the player palette. The default value is this. What we actually want to do is we want to use this one. However, this is not a player palette. So we need to, again, copy all the palettes and do player palettes. So we'll just call this one like this. Why do we need to do this? Because he basically takes, the player palette works as follows. He takes the default palette, which can be defined, and then he will just, basically take this palette, change the player colors, and write a new palette. And he will do this for every player in the game. So everyone has his own palette which is being used. So we need to define the correct player palette. So let's do this for now. And as I'm lazy again, as we all know by now, I will just do something like this. Okay, now we have a pattern matching every of these palettes. And we basically want to use the special trait for this. Player. There's a player color palette. So we basically need this one because this is basically the number. The palette number, and we are generating a new pair of traits here. We're using this $1. It's basically everything in the first brackets here. And after this, we basically generate a. Can't I just press enter? No. We generate a second palette, and let's just call this player. We don't need this, and I will tell you why. So this is basically the player color palette trait. This one. It has a base palette, which is the palette which it should be based on. So instead of doing this, we will just say, okay, this is the palette we want to base this on. It should get a, what do we have? A base name instead of name. Okay, then just call this base name. This is the prefix. Well, yeah, this is the new palette's name. It will just be appended with the correct player identifier. Oh yeah, we need remap index because actually this tells us which colors we want to replace for the player color. If I remember right, where we had the first 4 tracks, and then we had the 4 muzzles, and then we had the 4 player colors, and then we had the 5 player colors. So it should be something like it should definitely be this. Wait, do they need spaces or do they need commas? Let's just look how the other ones are doing this. Rules. Looks like they're using commas. Yep, they're using commas. So so they should be these. Because they will fit on all the palettes because we compared 2 of them and they always have the same bottom line with special meanings. So okay, now we want to go here. We want to do this. Just why doesn't he? Oh no, wrong one. Here. Okay, it's matching. We want this setup and just to replace all. And now we have basically our base palette, which is being loaded, and then we have the player color palette, which basically tells him to replace these colors in this palette and call the new palette this. So now we have the player palettes for all the palettes. Yeah, so we quickly generated a lot of traits. Yeah, so okay, let's give him this palette and let's see in game if it works. No, what does he say? Cannot locate type render. Okay. I'm stupid. Because it's, I think it was render sprites. Let me check this. Renders. Yeah, it's render sprites. Okay. Let's get in game.
Battle control initialized.
Oh, affirmative.
Build instruction complete. Build unit ready.
Here we go. We have the palette.
Yes, acknowledged. Affirmative.
Yeah. So for now we have a palette. However, there's something I want to show you now. In the we still have this problem. Pretty interesting. We will look about this later. Let's start this up again. The player palette has actually a big problem, which I'm going to show you now. Let's use this one. So, can we apply? No, we cannot. What's actually the palette stuff doing? The player color palette. Here it is actually generating the new colors, and here it is reading the original palette. What does this mean? It basically means that the new player colors are being generated without the usage of the original palette. So what this trait won't do is take the color from the palette and basically keep its brightness and give it a new tint. It will just replace all the player colors we have defined here, and basically start here with a dark one going to the brightest one, and it just generates a new a new color range. So this basically makes the player faction pixels look wrong. This works on the standard OpenRA mods, but as I noticed when developing the KKND mod, this definitely looks bad on all other games. So what I want to do here is basically replace this one with a custom trait where we are actually doing our own coloring logic. So yeah, wait a second, I have too much things open. Okay, so we will use a Photoshop layer effect. Okay, it's basically a blend mode, but yeah, when I searched for the correct coloring algorithm, I searched for the Photoshop layer modes, and then I found one which actually looked very good, which was called overlay. So we will just call this overlay player color palette. So this will be the new trait we are building, and oh yeah, we are not going to completely build this because there's some math in there. I will be using just some copy and paste now. Okay, so we have overlay player color palette, and I'll be just copying my my contents from the KKND mod. Here we are. Let's import the missing stuff. Actually, what it does is it takes the original palette first, and then it goes over the remap index stuff, and basically calculate the correct black and white value, so the grayscale value of this pixel, so we have the correct brightness, and then it will apply basically this formula here on the black and white, on the grayscale value for every channel, and then it will put it back together in one palette. So except this will basically it will take the original color and keep whatever is in the alpha channel, so it won't be changed, and everything here will basically be overridden by this formula. And this actually goes to a point where it checks if it's brighter than I'm using floats here, I know. It is brighter than half bright, it will use basically this, otherwise it will use this. And that's actually the formula behind this blend mode, which in my eyes, or in my opinion, looks very beautiful on the OpenRA actors. So let's start this up.
Battle control initialized.
Affirmative.
Build instruction complete. Build unit ready.
Here we are, and as we can see now, these I'm playing some kind of pink, purplish, and the color here was way brighter before we added this this overlay player color thing, and it now takes the original brightness of the pixels with the correct color, of course.
Affirmative. Affirmative. Acknowledged.
Okay, what we can actually see is that it rotates in the wrong direction, and we of course have the wrong number of facings. So we have to fix that. And this seems to happen sometimes when we look north and then we need to look to the right. Yeah, but we will need to redo the facings anyway. Okay, let's close everything. What have we achieved so far? We have the unit in game. We have the palettes, the beautiful version of the palettes, and well, you could actually think, hey, that's awesome. We want to do more. The next thing we want to do is the muzzle was actually visible all the time, because there is no dedicated frame for when a unit shoots. They are basically attached to all the frames. So we are basically removing this pixels and set them to transparent, so you won't be able to see the muzzle anymore. And there actually were 4 muzzle values, and they were I made some notes. They were here. So basically, let me just. This is the muzzle flash, the shadow. This is transparent, and so much for this. Let's check in game, and now there shouldn't be the muzzles on the unit anymore.
Battle control initialized. Build instruction complete. Build unit ready.
Yep, as you can see here in front, they are gone. We will add them later again, however, with the correct behavior.
Yes, sir. Affirmative. Acknowledged.
Okay, so first let's get this facings fixed, because that's actually something which bothers me. This looks bad. The problem with the facings is actually that OpenRA is using a facings variable, which wants the unit to be completely rotated from top once around. However, in Earth, we only have the units facing north, and then it goes clockwise to south, and there are no facings where they are looking to the left. So basically, the original game is just mirroring this particular frames. So what we can do basically here is there is some support to basically name all the frames you want to use, and there you can basically tell every frame you are mirrored or you are not mirrored, whatever. And so you can manually, it's called combine. You can manually add all the 16 frames here, and every frame has its own start value. It has its information whether it should be flipped on X or not. And then you can basically use the correct facings of 16. Let's just add this here. And it will basically, instead of starting here and taking 16 frames, it will basically take the frames you're building, or the frame list you're building together with Combine. So that's what we want to use. However, we are lazy again. We don't want this huge bloated sequence files, because there will be, this will be stupid because all units work the same. So instead of doing this, we will basically write some code which automatically does this for us. So basically, yes, we need to list all the frames we want to use. So what we want to do is we want this frame, and we want this frame. Just let's list the 9 we have. So these are the frames we want to use. And we want basically to automatically generate a reversal of these appended here on the end. And these frames have to be flipped on X. So you basically would do this, flip X, something like that. But we don't want to type that, but this should be enough. But this tells us which frames we want to use. And this is what we are going to work with. The same applies to here. We are basically going from here to 43, 44, 45, and so on. Okay. And we are writing code which reads this and automatically builds our combine block. So as we know, build a combine block, we will then again start at 0 of this combine block. I think, there is the default, but actually we are overriding tanks, so whatever the start is in the original idle and turret has to be overwritten by 0. Okay. The last thing we need to add is basically we need a custom property. So we know that we want to do this logic on this block, but not do the logic on any other block, like the standard OpenRA tanks and whatever. And for that, we are basically giving him a custom property. Let's call this flip facings true. So we are basically searching for this key, and if it's there and if it is true, why also check for true, because you can set it to false again. So we will check for this, and if it's there, we will basically read this, and use the middle part, reverse this, append it, and flip this. So we will basically have the correct result on the end. So these sequences are actually parsed by the sprite sequence. So the default one is the default sprite sequence, and here you can basically see here's the combine block, which basically allows you to select individual frames. Here are all the things supported, like start, number of frames, flips, facings, whatever. And we want to do our own one. So as you can see, is in common graphics. So you basically do another namespace here called yes, we call this graphics. What? Okay, so we call this graphics, and we will add a class. You know what? Let's call this Earth 140 sprite sequence. Because basically, yeah, it's just a sprite sequence with some extras for Earth. Now we need to look what the default one is, which is Earth currently using. It's using the tileset specific sprite sequence. So this is what we're going to extend. And yeah, we are basically, yeah, we want to override some stuff here. We don't need I think we don't need a different constructor, but we can actually override some methods. And no, we don't need. What we basically want to do is this is the info thing is the mini YAML block. It's just basically this was get parsed into the sprite sequence. And we need to modify this because, as a matter of fact, I know to be able to edit a sprite sequence, you basically need to edit the sprites here, which is no problem because it's protected. But you also need to edit this frames thingy, which has a private setter, not a protected setter. So we cannot, change the contents of this value of this property in our custom sprite sequence. And as we we could simply make this protected, but we want to be compatible with the OpenRA core. We don't want to change anything of the default files. So what we're basically going to do is we are on the fly generating at this position. We are generating the YAML, the whole combine block by ourselves. So the correct sprite sequence is basically getting this, including a automatically generated combine block. So it will work as it should work. So the default sprite sequence or the tileset specific sprite sequence will basically do all the work for us we want, and we don't need to copy a lot of code. Because if you look into this, where it is here, this method here, the constructor is basically super long, and we would have to copy all of this just to implement this little extra. So we will basically fake this one, and yeah, that's what we're going to do now. So and here we will just say flip facings. Now we'll generate this method. Okay, so now we are able to manipulate this here. Yeah. So if I remember right, let's see here. Yeah, it mostly starts with this. It takes the info thingy and creates a dictionary from it. And the really first thing we need to do here is basically check if our custom flip facings property is in here and it is true. If it is not, we do not want to touch this info at all. So it has a load field, brackets. There is a load field method in the sprite sequences here, which basically allows us to load anything from here. So we're just telling, okay, this is my dictionary, and I want to load flip facings, and the default is false. So if it's not there, it will be false. And only if it is there and it is true, then we want to basically apply our logic. So if this matches, we will basically return the original info thing unchanged. Whatever else we are doing, we will also return info, but at this position we will now change whatever is in there. So what we need to know is, wait, let me find an example combine block. Here we are. Combine looks like this. You basically have a combine property, and then these are the file names. Inside the file names, you can now select a specific amount of frames and give them some properties. Yeah, so let's start. First of all, what we want to have is this. This is basically the first line of our YAML, our combine line. The next thing we want to do is basically we want to append all the combine blocks. So we need a for whatever is in here. And what we want to add is basically the next line. So we need a tab in front, of course. We need a break at the line end. And what we need here is my file mix. And then we need another line break. Then we need 2 tabs. And then we need a start. Why did he? Then we need start, and then for example, we want 1, 2, 3, 4, 5. Oh yeah, and the problem is he will actually do the same here. As you can see, there is no .shp here. So yeah, like here at extension false, you need to do the same on all the combine stuff. So after this, we are basically doing a line break. We again do 2 tabs, so we are just yeah, at the right position, and then we do add extension false. This is basically the line we want to have for all our frames. No, not for all our frames. So we need a second block, because if we go over all the frames, we will exactly have half the frames, the same as we had before. But we want another block here, which has one more line. And this line is basically flip x true. So what we're generating here are the facings for the other direction, which are missing. And if we are complete with this, we now have our complete YAML here. Then we can actually go to the info block, and yeah, these are the nodes, so everything in here. And we will add our custom node. And it wants a mini YAML item. Okay, so I think mini YAML has, yeah, it has a from string. And we just tell him, wait, what do you want? He wants 2 strings. First the text, then the file name. We don't need a file name. Method from string to okay, he there's a turns of the list of multiple items, so we basically want the first thing, because we only have one thing at the most top. Yeah, at the root we only have combine, and everything is inside combine, and we don't have another property here, so we just add the first thing here we get. So yeah, this should basically add our custom YAML, which is generated on the fly to the info, which then gets parsed by all the default methods. So this way we could get around of doing a lot of ugly stuff in the sequences, and it also gets us around to copy this whole sprite sequence parsing stuff. The only thing we actually need to do now is to yeah, correctly populate this. So the first thing we need actually is, if we look here, we need the frames. We need to iterate over them. So we now have this dictionary, and oh no, it's load field. So we just load field, this dictionary. We want to load the property called frames. And no, we don't have a default. Okay, so So null as a default value, so because we don't need any default. Why? Okay, it needs to be parameterized. Yeah, we basically expect an integer array. So we now should have all the frames in here which we want to load. And yeah, now we can basically go here and we start at the beginning and we go through all the oh, come on, today is not my best day typing. We go over all the frames and yeah, at this position here we basically want to use the correct frame. So we should now have one entry for every frame we have in our frames list. And here we need to do something nearly like that. We need the same ID here, but our loop has to be different. Because first of all, we want to reverse this loop. So in theory, it should be so -1, and then this is how it should be reversed. However, we don't need to clone the north and south looking ones, so we can do this and this. So now we go over the frames in the reversed order, and we skip the first and last one. So we get basically all the other angles, and we are appending them in the flipped order on the left, and we are flipping them. Oh yeah, one other thing we actually need to do is basically now we need, after we did this, we need to remove frames from the info because the default sprite sequence should not parse the frames anymore. So what we're going to do is, after loading this, is basically let's get into the info thing. Let's go into these nodes and let's remove. Oh, he wants the node to remove. That's a problem. Wait, I think we can search over these nodes. Let's use. Yeah, let's use first where the key is frames. So okay, so we will basically run over the nodes and get the one where the key is frames. So the original frames one, and we will remove this. So we will basically have removed this entry here and added the new combine entries here. Yeah, I think. Oh yeah, this here in the beginning. We need this, which is basically here, and we basically need to add this to every of our. Where was it here? Every entry here needs the correct. Yeah, the correct entry. Just so we need to get this value and also remove this from here and add this value here and here. So as we know, this is our YAML stuff. Let's call this source because this is source where we're getting the information from. We can just, instead of going over the nodes, get the initial value of this current YAML node mini YAML thing. So this is the mini YAML thing. These are the nodes inside. This is the key, and this is the value. So we are basically taking the value, and then we are basically nulling the value. So we don't have a value here anymore, but we now have this source thingy. And let's go here, wait, here and here. What was the key binding for this? No. I'm pretty sure there was a way to select. You know what? Let's do this. So we go here. Oh, we need the tab in the beginning. Then we need to stop. To add something in between. And yeah, the source. So now we have combined. We have a new line starting with the source. Then we have a new line with the start frame. Then we have a new line which disables the extensions, and this one has to be flipped. Yeah, so now we are basically generating this whole combine block, which then runs into the default sprite sequence and gets parsed as if it would be here. Yeah, this is getting removed. We could actually remove this one because it's actually a custom property not needed. But this default sprite sequence will not crash if this value is there because it's just not used. So let's see how this looks in-game. Booting up, and there's some mistake, I think. Okay, what are we doing? We are going over the something crashed. Let me see. Oh, of course. Now we need to go into the mod YAML. Basically, it's still using the wrong sprite sequence. So we need to tell him that he should use our sprite sequence here. So this one, please. Unable to find a loader. Yes, sprite sequences need a loader. Let's go with the other ones. If you look here, this is the sprite sequence for the tileset, which is doing tileset stuff. There's also a loader here. Oh, they are also extending the default one. So let's just copy this, and it just appended the string loader to the name. And this is what's missing. It actually added the constructor with mod data. And we don't want to do anything here. So basically, yeah, we just keep this empty. But this is the interesting point. We want to override this create sequence thing again because this is telling us which sequence we want to create. So just copy paste this stuff here and use this one here. So now basically there should be a loader which creates the correct sprite sequences. And the loader is not a loader. What? Did I forget something? Maybe we need to do a build. So the Earth 3140 sprite sequence loader is no tileset specific. Oh, come on. A stupid mistake. Yeah, we actually using this one. So we should not use this one here. We should basically extend this one. My mistake. So yeah, everything loaded up. And let's see in-game how it looks.
Battle control initialized.
Yes, affirmative.
Build instruction complete. Build unit ready.
Reporting. Acknowledged. Affirmative. Acknowledged.
So
Affirmative.
actually it rotates completely.
Acknowledged. Acknowledged. Affirmative.
But it's actually flipped. So yeah, this is pretty easy to fix. We will just reverse the facings. And here we go. Starting again.
Battle control initialized.
Acknowledged.
Build instruction complete. Build unit ready.
Waiting on affirmative. Acknowledged.
This looks nice.
Affirmative.
This looks really nice. But still, we have to do these tracks.
Acknowledged.
And we need to do the correct muzzle. So, okay. Yeah. So let's start with the muzzle. Where is my rule set? Here. And we need the original rule sets. First we need to disable the original muzzle, and we need to do our custom muzzle. So I'm pretty sure the original one is using some kind of with muzzle overlay. So let's look for to tank. Yeah, here it is. We'll basically remove this one. So the default red alert muzzle is gone. And what we want to do is basically we want our own muzzle to be applied. However, it is tied to the turret. Actually, we are just not rendering them. So what we want to do is basically build our own turret version, which if it is muzzle, if the muzzle should be displayed, so if it is attacking, it will just also render these pixels we removed. So we will do a custom turret version. So if you look here, it's using that with sprite turret, which is the default turret version. Yeah, we will remove this one, and we will call this with muzzle sprite turret. Oh, you know what? With muzzle palette, because you want this to work using palettes. Yeah, the next thing we need to basically do then is we need to write this particular trait. Okay, so let's first search for the original one. So it's basically with sprite turret. This is the one we are basically want to change or override. It's in a trait render, so we are basically doing the same folder structure here. Let's do a render namespace. Let's add this one. And we now need the trait info block. And we now want to return new with muzzles palette sprite turret. Come on, what a name. Okay. First of all, we definitely don't want to rebuild this whole behavior the sprite turret has with positioning and whatever. So what we actually want to do is just extend this one. And as we can see, it basically gets the actor and the info, so we can just get this from here. So the actor and the info. And we also need to extend the, where is it? There it is, the correct trait info thingy. So, okay. Now we have our custom version of the with sprite turret, which is here. And we can now start to override this with something we actually want. What we want to do is actually, we want to react if this actor is shooting. And if it is shooting, we want to draw the muzzle stuff. So we can basically implement the iNotify attack. So we have a preparing, we don't want to do anything on preparing, but we want to do stuff on action. And what we actually want to do is we want to render the muzzle thing. What we also want to do is we want to make sure that when we are attacking, it starts to render and it has to stop to render. So first of all, what we need is basically where is it? We need, I think, no. Where is this? We need this block. Let's copy this whole block for now. Let's copy this in here. What we need is we need the render sprites. And seriously, let's call this render sprites. Let's put this here. Don't need this one now. Let's first implement everything that's missing. Let's add some vars. Okay. Not here. So in theory, this will be it. Now we can also see body is not used, arms is not used, so whatever, we don't need it. We need the render sprites, of course. We need this to get the correct turreted trait. However, we will call this turreted. Then we need an information if this thing is completely built. Okay, why not? So this is the name of the animation. In standard it's called default animation, but we will store this in muzzle because we want to play this and stop playing this when we do not need this anymore. So we'll just replace this ones, and yeah, basically this will render this thing on top, this muzzle thing, with the correct turret offset, so it will always correctly align to the turret. That's why we're actually copying this whole block. However, it will always draw. If you now look at animation with offset, there is a disable function, which is basically this. So whatever is in here, it will disable this. So the most interesting thing is actually what we can do is basically we can come on, let's call this fire. Let's have a bool property here, and we only want to show this if fire is true. So in the disable function we say, okay, if we are not firing, we don't want to see this thing. So no muzzle if we are not shooting. Yeah, and at least when we're attacking, we set this to true, and then we basically need to yeah, we just play this once. So let me look up how this is played here. This is how it works. Let's copy this. Basically, I'm using a play then because this bool has to be set to false again. So for now, okay, let's use the muzzle, and then we say, okay, play then this thing, actually. This is the sequence we want to play, so basically the same sequence as the turret. Basically, we are rendering the complete turret on top of the turret, so it always matches. However, we are using a different palette then. So, okay, when this is done, okay, we can keep this cancelled, but we need to set fire to false, so this custom palette version is not displayed. And I think play then... oh no, okay, yeah. So in theory, we will now draw the whole turret twice. I think it was an animation with offset. What was the add? Yeah, the add. It actually has a new parameter called string palette. So yeah, it's a string type and it's a palette, of course. We can basically name the palette here. So we will just render this with the muzzle palette, which we now need to define. So the second turret, which is basically rendered on top of the turret, will now be rendered with this palette. And yeah, this is pretty easy to do, because what we actually need is the opposite of how we are handling the muzzle now, which is basically setting it to 0. So we will basically just copy this whole thing. Let's call this muzzle palette. So this muzzle palette, okay, let's rename this one. No, it's this. This, okay. And here we need this. However, we need the name, yes, but we don't need this and this. Why? I can tell you. The muzzle colors were placeholder colors. Same with the shadow, they were red basically. So we cannot use the original ones here as they are placeholder colors. we need to add the correct colors here. So we'll basically remove everything from reading or whatever. We don't need this one, and yep, and this. So basically, this is all we need to do. Let's see. Okay, we can clean a little bit up. Yeah, basically, this is what we want to do, and we want these pixels to be visible. And now we can basically add the correct colors here. However, they are not in the file, and to be honest, I cheated a little bit. I looked into the original executable and found the colors. So I actually prepared the correct color values, so because I knew we are going, we needed them, and to do not make this video longer and longer just to get this for values, I just yeah, I have them here. So this one, this one, this one, and the last one is this. So this is actually the color palette. This is a hard color palette which is all transparent because we don't want to run anything besides this, and this is the correct color we want to use. So yeah, so much for that. We now need the palette added to the YAML, because otherwise it won't be available. So we just go here, and we don't need this anymore. We will just say the class type is muzzle palette, and because there's only one, we don't need this add stuff. And we name this muzzle. And this is everything we need, because we are just having one instance of the palette. It has an internal name muzzle, which we are referencing hard actually in our custom turret. Stupid me. Yeah, actually, we're extending another trait, and we do not override this method. So yeah, he says make override. So basically, what it did now was actually using the old method now. So okay, now we're using the correct one.
Battle control initialized.
Acknowledge.
Build instruction complete. Build unit ready.
Okay, I see the magic happen. There's a shot muzzle effect here. So yay, we've implemented the muzzle thing.
Yes, acknowledged.
So two more things I want to do in this video. Actually, these tracks are ugly, and they have to rotate when the unit moves. This is what we're going to do now, and then we basically have everything which is special about the RS 3140 sprite format implemented, because all units are relying on these special special traits for the last row of pixels in the palette. First of all, let's get this this move animation implemented. Basically, we need to modify the palette every tick. However, this might result in a problem, as the palette is used across all instances of this unit. So if one unit moves, in theory, all of them would basically be animated. And to get around this, we basically need another palette for each of the palettes. Not for each of the palettes, because we only need this for units where this applies, so we will not generate them like we did before, because we were lazy. We will manually do them where they are required. So what we want to do now is, I think it was 72, this one. Basically, we need another version of this palette here. Let's copy this, and let's call this, and let's just add the string movement. So this is a complete copy of the default player palette, with the only difference, this palette here will contain a palette animation which moves the tracks. So yeah, that's that. For now, because this just for the palettes, I think we will just move add this here. So actually in world, we can have a custom trait, which I think it's called rotation palette effect. So this one is basically the palette effect, yeah, which basically goes through a specific amount of colors. You tell him a base where he should start and how many pixels, and they basically rotate these colors, which is exactly what we want for the tracks. So yeah, let me see. They were the 4 in front, so they should be 240 and 243 because they are here. So yeah, where was I? There it is. We need the rotation base, which is 240, and we have a rotation range of 4. So basically, this is where we want to move, and now we need to define all the palettes which this applies to. So for now, we just have 1, and this is the number here. So we just copy this one. This is what we want to use. So let's see in game. Oh no, this still doesn't work in game because we forgot the most important thing. Actually, we now need a trait which dynamically changes the palette depending on whether the unit is moving or not. So we will just go here and we will do another trait. Because this is for moving, just call this with move palette. So this trait has to do exactly one thing. If the unit moves, change the palette, and if it doesn't move, go back to the default, which is here. So yeah, let's okay, we have these with things here, so yeah, let's just add a with move palette trait, and of course have the info thing too, which is a basic trait info, and it has to do exactly one thing. It has to return the move palette thing here. Oh, what we also need, just copy this here. I think it would be the best. Should we call this player? No, you know what? Let's call this. I'll just call this palette. Movement. I think I called it. Yep, movement. We just name the palette which he has to use when the unit is moving. So we will just swap this to this. Yeah. So now we need to create the this thing here. Let's just look at render sprites, how they are defining a palette. So this one here is what we want to do, or what we're going to have. Let's copy this here, and it's not called this player palette, but just palette because it's just for our, yeah, for our actors, and we know we just need this one. Yeah, so we're actually setting this one, and we don't need the default value. Let me think. Here's a power reference. So, you know what? Just set this null, whatever. Let's call this custom palette. Custom player color palette base name when moving. So, okay. What we now need to do is basically we need to depend on if the unit is moving. So there's actually a trait. I think it was iMove. Yep, it's iMove, which is basically has a bool if something is moving or not. Which is basically handling the move stuff. So we now need this particular trait, so we will just implement a constructor. And what we need now is we need the move thing. Come on. And we need to get the move trait. So in theory, it would be something like in itself. As you can see, we don't have init, so we just need to give him init. Oh, and we need to give him, of course, the info because we need the palette name here. So okay, let's create a constructor with that. Move this here. Let's call this again info. Okay, here we go. We want a specific trait. Basically, we want the iMove trait. And let's store this into the move field. So here we go. This might crash, of course, if it depends on the load order. But we can influence this by basically doing a requires iMove info. So now this one requires that this one is loaded before. Okay, so we have the movement. Oh, and we need to store the info because it's very unlikely we need it in the constructor, but we will need this later. Let's move this to the top. Okay. What we don't want to do is basically modify the palette on the fly before it is rendered. And I actually did a little bit of research. There is actually a interface doing this, and it's called iRender modifier. Basically, the iRender modifier. Let's quickly add this stuff. So this is on the bounce, and we don't want to change the bounce, but we want to change this. Renderables. So when this actor has to be rendered on the screen, this method will receive all the stuff which has to be rendered, and we can modify it here. So basically what we can do is we can modify the vehicle base to the moving vehicle base if we need to, and this is basically called every time this thing should render. So yeah, we just need to select the correct renderables, and then dynamically say, okay, because it's resetting every time. So if it is moving, then we will replace it. If not, we will just do nothing because it will be the default value. So what we want to do is basically we want to return the renderables. However, we want to modify some of them. So we just do a select. We will get a renderable. Make a block of this because it might contain more, and in theory we want to return the renderable. So like this. However, in a particular case we want to replace this. When do we want to replace this? First of all, we want to replace this thing if this thing is moving. So if move is moving, then what we want to do is basically, I think it has, with palette. So we can now overwrite the palette with another palette, which would basically be info palette, but it doesn't want a string, it wants a palette reference, if I'm right. Yep, it wants a palette reference. So we need to get the palette reference, which we can get from the world renderer. And then we just say here, palette, this one please. And this would work, however, we are speaking of player palettes. So what we also need to add is basically the internal name of the owner, because every player has its own player palette, as I explained before. Okay, and now let's just rename this thing something better. Let's call it world renderer. No, not everywhere. I'm gonna just do this. Okay, so basically we are now replacing all renderables. So if the unit has anything else like a hitbox which has to be rendered, unit selection frames, health bar, whatever, the turret, the muzzle, everything, we will replace this all. So we only want to replace the usage where we are actually using the default player palette. So basically what we want to check, if the palette is the default one, then replace the default player palette, basically this one. Then we replace it with this one because that's what we change. But everything else, which is a different palette, we don't want to touch, so we don't mess up the stuff. So yeah. So first of all, if it is moving, and now let's get the renderable. And does this has? Oh yeah, it has a palette. Nice. And this one has a name. Okay. And as we know, the player palette is appended by this. We'll just I know. We basically now need to check for the opposite. Basically, we want to check for this almost, but not info palette. But we need the palette from here. We just render sprites player palette. So we want basically the render sprites info and the player palette, which basically means we now need the render sprites here too. So let's require render sprites, and let's store the render sprites. So in renders, in the info thing, and we don't need this. Sorry for that. Reverse this. So we just need this info thing from there. So we can basically we can go to the info stuff and get the trait info for render sprites info. Store this. So now we have the correct info block. So it's basically just this, not the trait instance. We don't care about the instance because it's defined here. We just want this value from the info stuff. So yeah, we are getting the render sprites thing, which is here, and checking if the name of the current palette which should render is the player palette, appending with the player internal name, which is basically the palette it is using for the vehicles. And only if it is moving and the palette matches, then we are basically going to return the different palette. This is basically this one, so this one. And this palette is basically being rotated by the rotation palette effect. Because there might be more rotation palette effects here, we just call this movement, because otherwise I'm not sure if the default mods define any of them, and I don't want to override them. So yeah, let's test this out.
Battle control initialized.
Acknowledged.
Build construction complete. Build unit ready.
And here we see,
Comrade,
there he stopped.
affirmative.
He's moving. Oh,
Acknowledged.
and actually he's moving backwards. Moonwalking tanks.
Affirmative.
Perfect. Let's call it the Jackson tank. I don't know. So yeah, we need to flip this effect. And we need to add the correct colors. So yeah, we need to flip the effect. We need to add the colors, and I think, give me a moment. I think we should be completed then. Yeah, I think we are. So, okay, rotation palette effect. Can we reverse this? Let me see how it works. No, we cannot. Basically, this won't work if reversed. I was happy to get around this. So yeah, it's in trait palette effects. So we will just make our custom palette effect. And we'll basically copy this one here, and it's called rotation palette effect, and we will just call this one reverse rotation palette effect. I just copy all of this. Let's add reversed. Let's implement everything which we are missing. Here we go. Okay. So actually, this thing. Wait, this has to be changed. Okay, is doing more than we need. Because in our case we just need this palette stuff, so we will just clean up a little bit here. Because yeah, it's way too much. This is the tick helper, so let's call this ticker instead of T. Okay. So using a lot of tilestat stuff. So you know what? We don't have an exclude. We don't need this one. We just need pilot's rotation base and range. And let's keep the rotation step for the speed, which is okay. We don't need this one. We have the ticker. We don't need a. What's the tilestat? Yeah. These two things, we don't need them. We don't need this. We don't need this whole method. We don't need this. We don't need this, of course. This is basically... we don't need this. Oh, wait. We don't need this at the end, so... Okay. Yeah, and we need everything else. So this is a copy I like. Let's remove this. You know what? This is ugly with a float. Let's use an integer. Without private. Rotation step. Let's make this 1. Let's make this also an integer. And so we don't need to do this. And to get somehow the same values, we just use this one. So, okay, what else do we have? Oh, we don't need the world anymore. So, go away world. So the ticker will be bigger, okay. And this will mimic the same behavior, basically. Now we go here. Okay, this is basically it. It goes over the palette, it gets the correct range, which is okay. And it applies the range again, but this is basically where it has been sorted. And what we basically need to do now is the range should be here, yes, but we need to subtract this, so this goes in the other direction. However, we might get into a negative value, so we will just add, no, we have this range here, just then use the variable. So okay, we will add 1 to the range. So we always start with bigger values because they will basically be capped here. And I think this should be it. So let's try it out. Let's use the reversed one. Let's click play.
Battle control initialized.
Acknowledged.
Build construction is complete. Build unit ready.
Comrade, affirmative.
And it rotates in the right direction. Nice.
Acknowledged.
So the only thing we're actually missing are the tracks. And I also cheated on these because I looked also up these correct color codes. Yeah, actually they are the same for all. There it is. Basically the tracks were in here, and the tracks are using the 4 index before of these. So let's call this tracks, and we have 3, 2, 1, 0. And as I said, I already know the correct values, so this. And there's actually a funny thing. They use this color twice. So this is basically hard-coded in the original game. So yeah, we can just also hard-code this for now because this is for our mod, which should be basically this game. And all the tracks should have the correct colors.
Battle control initialized.
Yes, affirmative.
Build instruction complete. Build unit
Waiting
ready.
order. Acknowledged.
I would say this looks good.
Comrade, acknowledged. No problem. Affirmative. Acknowledged. Affirmative.
Yeah, here we go. This is basically what I wanted to achieve today.
Acknowledged. Affirmative.
We now have the first actual visible unit from Earth in-game. We are completely done. We have the color support, we have moving tracks, we have the complete facings, the palettes, yeah, the muzzle palette.
Comrade, waiting order.
So actually, all it's missing is basically some YAML adjustments, like the correct hit shape, yeah, adding sounds, behavior, stats, unit name,
No problem. Acknowledged.
whatever.
Affirmative.
But
Yes, sir.
on the asset side, we are complete on this. I think in the next video I will continue and quickly implement the sound loaders. So this will be a very short video. It basically depends on if I manage to get the tile set working till then, because currently there is no support for 32-bit colors on tile sets. So yeah, I hope I get these two things in one video, because only the sounds will be a little bit less. If this takes too long for me to implement, then I will make the sound thing first, and we have a short next video. Otherwise, yeah, I think a week or two we should have at least the video showing the target implementation. And then we are complete on the asset side, because when you have support for that, we could basically implement all what's missing, and then we have a perfect start to basically make this mod standalone and not use a red alert at all.
Waiting order. Affirmative.
And yeah, finally find some
No problem.
yeah,
Acknowledged.
complete the
Affirmative.
tutorial series then, because we have it in game.
Acknowledged.
Oh, you know what? Maybe I will do at least. No, we have it then in game, and everything else is not as related. It's just ordinary OpenRA alert, or then we have it in game, and everything else is basically OpenRA, yeah, mod coding, which is basically, yeah, most people are. I guess you guys already know how to do it if you watch this video. Yeah, so that's it for now. I hope you enjoyed this video, and yeah, see you next time when we are going to add the other missing stuff. Yeah, thanks for watching.